Okay, so now continuing with the concept of a point basically dividing a line in externally in some ratio. So basically what we had was that we had some line over here, some line segment over here. Let's say we had this line segment, for example, A, B, and C. And we said that basically AC to BC was equal to 3 to 1. Was equal to 3 to 1. And we wanted to find, and we assuming that, for example, the coordinates of this point is x1 comma y1, and the coordinates of this point are x2 comma y2. We want to find the coordinates of this point, and basically let's say that, for example, AC to BC, let's call this, for example, this ratio, not exactly m, but the ratio of these of AC to BC, let's call it, for example, m to n. Now we want to find the coordinates of this point C in terms of x1, y1, x2, y2, and this ratio m to n. So for that purpose, we need to use the concept of the basic proportionality theorem. Basic proportionality theorem, or basically in short BPT, which we talked about in the previous video. So what we can do in order to achieve that, in order to get to the coordinates of this point C, what we can do is that basically you need to do a simple construction, meaning that you basically suppose that you have this line segment over here, AB, for example. From this point A, you need to draw a ray, any ray basically, something like this, and call it, for example, X, AX, basically, ray AX. Now on this ray AX, you need to use a compass. You need to use a compass and mark 3 equal distances on this ray, meaning that you open your compass to any basically, to any distance really, to any diameter really. Any diameter would do, but it doesn't have, it cannot be, well, I mean, they have to be reasonably spaced, meaning that, for example, you put the needle of the compass, you put it over here, and then one marking over here, for example, another marking over here, and another marking over here. And remember that the ratio that we want to pick on this line is basically 3 to 1. That's why we make 3 markings over here. And you need to imagine that these distances are exactly the same using a compass, basically. Now, since that is 3 to 1, you can call these points, for example, P, you can call this point Q, and you can call this point R. And so And so you can join Q and B. You can join Q and B in this way, meaning that join Q and B in this way, and then you need to draw a line through R. You need to draw a line parallel to QB, something like this, for example, and call this point, for example, point Z, for example, and this point you can call it C. So what that means is that, as you can see, the ratio over here is basically these distances are equal, meaning that AP is equal to PQ is equal to QR. And so for the same reason, of course, AR is equal to AP plus PQ plus QR. If I call this distance, for example, some variable A, then AR would be equal to basically A plus A plus A, which is equal to 3A. AR is equal to 3A. Now, as you can see, this basically over here is of course a triangle. And using the basic proportionality theorem, we said that if a line segment, if a line is drawn parallel to for example, to the base of a triangle, it divides the other two sides of the triangle in the same ratio. So that means that AQ to basically AQ to QR is actually equal to AB to BC by the basic proportionality theorem. So now AQ is nothing but basically since I call basically AP, for example, A, then AQ I can call it 2A, and basically QR I can call it A. And AB to BC, AB to AC to well, it's a little bit confusing here. I don't know how to exactly get to what I want. I want to show that I apologize for this. I want to show that AC to BC is equal to 3 to 1. And the way that I can do it is that first I need to find AC. So basically by the basic proportionality theorem, since BQ is parallel to RC, then I can say that basically, for example, you can say that AC to BC, for example, AC to BC is the same thing as AR to, this is an R, is the same as AR to basically AQ. Of course, the original theorem was basically if BQ is if BQ is parallel to RC, then basically AQ to QR is equal to AB to BC. AB to BC, meaning that this distance to this distance is equal to this distance to this distance. But if that is the case, you can actually prove that AR to AQ, AR to RQ is equal to AC to BC. AC to BC. It's possible to show this. So I write the same thing over here. AC to BC is equal to AR to RQ. This has to be RQ. This has to be RQ. Now, in terms of the construction that I have here, basically I know that basically this AR is simply 3 units, and that is basically 3 units, and QR is basically 1 unit. Basically AR is 3 units, and RQ is 1 unit. It's 1 unit by construction. So what that means is that then you can write AR to RQ is equal to 3 to 1. And that is equal to AC to BC. Therefore, you can say AC to BC is equal to 3 to 1. So that is basically how you can do this kind of thing. And now this was in terms of the ratio. This was in terms of finding the locating the point R in terms of the ratio of these basically of these distances over here. Now what we can do is that we can basically revisit the problem of external division of a line segment by a point from the perspective of the coordinates okay. Now what that means is that, of course, I did make a mistake over here. I mean, I started with the assumption that we were doing basically this kind of thing, meaning that we had the coordinates of the point A and the coordinates of the point B and the ratio of these two distances, and then we wanted to find the coordinate of C, which was actually not what we actually did over here. Over here we did something a little bit different. But of course this is also useful in many situations, and you have to know this anyway, so it doesn't really hurt to go through this step. Now what I want to do now is do exactly this thing that we talked about before. So now we said that basically the line segment that we had, let me draw a coordinate system, and suppose that the line segment that we have is basically some point A, for example, over here, some point, for example, B over here, and some point C over here. And this is your y-axis and this is your x-axis. Now if I take the coordinates of this point as x1, y1, take the coordinates of this point as x2, y2, and take the coordinates of C as h, k, and if I know that AC to BC, is equal to m to n, the ratio, then now we want to find a point C. We need to find the coordinates of the point C, which divides the line segment AB externally in the ratio m to n. Okay, and well, we defined that the point C to have coordinates, for example, h, k. Now if you draw a line parallel to the x-axis over here, and if you draw two perpendiculars to these two lines like this, then you will have basically two right triangles over here. And I call this point A, this point call it B, this point call it C, this point call it, for example, P, and this point call it, for example, Q. Now the coordinates of these points we already know. The coordinates of these points, your x coordinate is over here is x2, and your y coordinate is y1. The coordinates of these points, your x coordinate over here is h, your y coordinate is y1. So now basically the distances that you can see over here, AP and BP and AQ and CQ, AP, BP, AQ, CQ, these four distances, you can write them in terms of x1, x2, x1, y1, y2, and so on and so forth. So let me take a few minutes break, and we will continue with this. Okay, so now these distances over here, so for example, you can write AP as so the distance between, so you see that basically the 2 points have the same y coordinates. So that means that then the distance between 2 points is of course going to contain only basically x2 and x1, meaning that you can write AP is equal to x2 minus x1. Here your x coordinate is x2, here is x1, so the distance between the 2 points is x2 minus x1, and there is one. So suppose that, for example, you have this. Let's have an example over here. So, for example, let's say you have this point over here. Let's say that this is x is equal to -5. There's a point over here, for example, some point over here, and the x coordinate over here is -5. So let's say that there is a point over here, the x coordinate over here is +2. So if I take this as, for example, x2, and if I take this as x1, then you know that the distance between these 2 points is 7 units. You have 5 units here, 2 units here, is 7 units. And if I calculate it in the same way using x2 and x1, meaning that if I write basically the distance, for example, let's say P and Q, the distance PQ is equal to x2 minus x1, that's going to give me basically 2 minus -5, which is equal to 2 plus 5, which is equal to 7 units. So that's basically why we write basically x2 minus x1. So the distance AP would be x2 minus x1. Now, there is another distance over here, which is AQ, and that is equal to basically the y's are the same, so h minus x1. There is the distance BP over here. Which is equal to, so the x's are the same. So that's y2 minus y1. The y coordinate over here is y2, and here is y1. So that is y2 minus y1, and CQ over here. And CQ over here is equal to, again, the x's are the same, so k minus y1. So, since these two triangles, basically, since triangle basically APB, this triangle over here, APB, is similar to triangle AQC, you can write AP to AQ, you can write AP to AQ is equal to AB to AC, is equal to AB to AC, is equal to BP to CQ. BP to CQ. So you can call this equation number 1. And I hope, and I'm sure you're familiar with similar triangles. You know that basically there are two ways that, there are two such concepts related to triangles. There is congruency, and there is similarity. But of course, I'm not going to talk about this right here because it would need a whole complete many videos to explain basically what is congruency and what is similarity. But suffice to say that if two triangles are suffice to say that basically similar triangles, what that means is that suppose that I have, for example, I have this triangle over here. Suppose that I have this triangle over here, and let's say that this is ABC. Now, what if let's say that for example this side length over here is equal to a, for example. If I take this a and multiply it by, for example, 2/3, if I take this a and multiply it by 2/3, that I would get 2/3 a. So then 2/3 a, for example, would be some distance over here. So then this distance would be, for example, more or less would be 2/3 a. 2/3 a, right? And then I can do the same thing for these sides as well. For example, 1 and 2, something like 1 and 2 over here, and then if I connect these points together, then suppose that this distance over here is b. If this distance is b, then this distance over here is going to be 2/3 b. And this distance, if I call this distance, for example, c, this distance over here is nothing but 2/3 c. So you can see that the main triangle that I had over here, the main triangle ABC that I had over here, I took the side length of every side of the triangle, and when I multiplied it by the same factor, 2/3, 2/3, and 2/3. And out of that I got this triangle, which I can call ADE, for example. Now, since basically every side length of the original triangle has been multiplied by the same factor to get this triangle ADE, then I can say that triangle ABC is similar to the triangle ADE. And there is then there are a few rules. For example, in the case of congruency of triangles, there is the side angle side rule. There is the side angle side. There is the there is RHS rule. There is many. There is a couple of these, like 5 of them. In the case of the congruency of triangles, which I haven't talked about here about. But now in the case of the similarity of triangles, again, we have some of these rules over here. For example, there is SAS, I suppose, and there is a couple more of these. And then using those rules, you can establish that, for example, 2 triangles are similar. Now, particularly in this, and particularly in this particular case, you can see that this angle over here is common between the 2 triangles. And this angle is equal to this angle, because these 2 lines are parallel. And this angle is of course equal to this angle, because again these 2 lines are parallel, and you know about the parallel lines and the transversal then in that case, for example, you would have if you have 2 parallel lines and then for example some situation like this, then this angle is going to be equal to this angle, and this angle is going to be equal to this angle. So based on that, you can say that then basically these 2 angles are equal, and this angle is of course equal to itself, common between the 2 triangles. And then based on that, you can say that the triangle ABC is similar to triangle ADE based on the angle based on the angle similarity rule. Now once you have established this, then there is all kinds of basically relationships between the sides of the two triangles, between the angles of the triangle, and so on and so forth, that you will have access to. And one of those things is basically the fact that, for example, there is a fixed ratio between the side length of between the corresponding sides of the two triangles. Meaning that, for example, if you say that ABC is similar to ADE, then the two triangles that you will get are basically this triangle and, for example, this triangle that is probably a little bit smaller than that. So suppose that now this is ABC and this is for example, DE. Now in these two triangles, these are the corresponding sides. These two sides are corresponding between the two triangles, and these two sides are corresponding between the two triangles. So then you can form a ratio between the corresponding sides of the two triangles, meaning that you can write AB to the corresponding side here, AD, is equal to AC to the corresponding side, AE, and then you can write BC to the corresponding side, DE. And then you can use this relationship in many different kinds of ways, in many different types of situations, for many different types of purposes, and so on and so forth. And now we are actually using this in order for basically in this concept over here, because we want to find these distances. So we can, using these ratios, we can basically find the coordinates of this point. And just to basically, of course, I didn't talk much about the similarity of triangles, but in mathematics we say that, for example, a circle with, for example, with for example this radius, a circle with this radius is similar to this circle. We say that these two circles are similar, irrespective of their radii, because there is always some relationship between the radius of this circle and any other circle, really, because if I take this A and if I take this B, there is always some relationship that you can find between A and B, meaning that you have to multiply B by some constant to get A. And so you can say that basically B is just a bigger version of this smaller circle A. But then you cannot, for example, say that, for example, this rectangle is similar to this square. It doesn't work like that. But then about these rules, we would need to talk separately for at least a few videos in order to establish all the necessary rules. But suffice it to say that in basically this is basically the gist of similarity of triangles, basically. And once you establish that your triangles are similar, then there is a fixed ratio between the corresponding sides of the triangles that you can write it this way. And now our triangles that are similar are basically these triangles, and these are the ratios between the side lengths of the triangles. So now I can write I can write this relationship between the side lengths of the triangles. So over here you can see that I have AP over here, I have AQ over here, I have AB, I don't have it, AC, I don't have it, BP, I have it, and CQ, we have it. So we need to do something about this because we have nothing for these two distances over here, AB and BC. So we know that AC to basically BC was equal to M to N. That was basically a given in this example. What that means is that I can write this as BC to AC is equal to N to M. Is equal to N to M. And so then I can write 1 minus BC to AC is equal to 1 minus N to M, which is the same thing as, this is something that is usually done in geometry. You subtract a 1 from, or you add a 1 to a fraction containing two sides of a triangle, for example, in order to achieve something specific. And what that is that, for example, now you can write AC, and that would be AC minus BC, and then over here you have M, and then over here you get M minus N. So then what that means is that AC minus BC is equal to AB, as you can see over here. So I can write AB to AC is equal to M minus N to M. Now this is AB to AC. So now we have all of these ratios. So I can write AB to AC is equal to M minus N to M. So now what I can do is just substitute these ratios over here and derive the formula that we were looking for. So AP is equal to x2 minus x1. AQ was equal to H minus x1. That is equal to AB to AC, which is M minus N over M, which is equal to BP Y2 minus Y1. CQ was K minus Y1. So what that means is that you can now, for example, take these two together, or H, basically H and so your H, for example, would be, so if you take these two basically fractions together, you will get so you will have okay, so if you cross multiply here, you will get HM minus NH is equal to plus basically MH. So you have H times M minus N times H. Let me write this again, I got confused here. So you have M times, or let me just write them this way first, and then we will take care of the rest. So H minus X1 times M minus N is equal to M times basically X2 minus X1. So over here what I can do is that I can write HM minus HN minus mx1 plus nx1, and then I can take is equal to basically m times x2 minus x1. So I can, over here I can take an h out, m minus n minus mx1 plus nx1 is equal to m times x2 minus x1, and so I can write this as so then I can take this to the other side of the equation, or I can actually take an x1 out, negative x1 times negative x1 times, for example, m plus n, and then write it as m times x2 minus x1, and then over here I have h times m minus n. Take this to the other side of the equation, h times m minus n is equal to m times x2 minus x1 plus x1 times m plus n, and so what that means is that then h is equal to m times x2 minus x1 plus x1 times m plus n over m minus n. Now, of course, you can simplify this a little bit. You can write it as m times x2 minus m times x1 plus m times x1 plus n times x1 over m minus n, and then these two will cancel out, so your h is equal to m times x2 plus n times x1 over m minus n over m minus n. And there is a problem here. I think I made a mistake somewhere over here. We said that basically this was AP, which was x2 minus x1, this was AQ, which was h minus x1, and AB to AC was m minus n over m, and BP was basically y2 minus y1, CQ was k minus y1, there is no problem here. And then if I cross multiply here, I'll get x2 minus x1 times x2 minus x1 times m is equal to m minus n times h minus x1. And so I have hm minus hm minus hn minus x1m plus x1n is equal to m times x2 minus x1. So I can take an h out, m minus n minus mx1 plus nx1 is equal to this. And so I can here, I think I made a mistake over here. So h times m minus n1 and negative x1, so that becomes a negative over here. Of course that becomes a negative because you have positive nx1, so you have to write it as that, and then take it to the other side of the equation. This becomes x1 times m minus n, and so what that means is that then basically h is equal to m times x2 minus x1 plus x1 times m minus n over m minus n, which is equal to which is equal to m times x2 minus m times x1 plus m times x1 minus n times x1 over m minus n, and mx1, you can cancel these two out, so you'll have m times x2 minus n times x1, n times x1 over m minus n. That is your h. And in the same way, you can derive this part of the, if you basically rewrite this equation over here, you can rewrite your k, which is pretty straightforward. We can do that as well. So if you cross multiply, you'll get m minus n times k minus y1 is equal to m times y2 minus y1. So if I cross multiply, I'll get mk minus m times y1 minus n times k plus n times y1 is equal to m times y2 minus y1. And so then what I want to calculate is k over here, so I take a k out from these two terms, k times m minus n, and minus my1 plus n times y1 is equal to m times y2 minus y1, and so k, or you can write this as k times m minus n is equal to m times y2 minus y1 plus m times y1 minus n times y1, and then you can write k as this whole expression, m times y2 minus y1 plus m y1 minus n times y1 over m minus n, and then you can rewrite this as k is equal to my2 minus my1 plus my1 minus ny1 over m minus n. Then you can cancel these two out. You'll get k is equal to my2 minus ny1 over m minus n. This is your k. So that is basically the coordinates of the point C over here, h and k, and this is your h, this is your k. So that was basically that. Now there is a couple more things over here to talk about, and this section formula is important. So let's do a couple of examples using the section formula as well, and then we will get back to what we were doing over here, which was the three-dimensional, the section formula in three-dimensional geometry.